Okay, so today we start looking at Fibonacci numbers. Fibonacci numbers. Okay, Fibonacci numbers are very special numbers. Mathematicians like to talk about Fibonacci numbers. When you are talking about number patterns, the first thing that many people think of is Fibonacci numbers, because there are a lot of patterns in Fibonacci numbers, and Fibonacci numbers can be seen in nature. That's why a lot of people find it very interesting. Okay, so this is the sequence of the Fibonacci numbers. Okay, 0, 1, 1, 2, 3, 5, 8, and so on. So what is the pattern that you can see here? This is the first term. Okay, 0. What is the next term? 1. And then how do we get the next term? What is the next term here after 34? Do you see a pattern here? 0,
Quite.
0 plus 1, 1, 1 plus 1, 2.
55.
0 plus 1 is 1, okay? So 1 plus 1 is equals to 2. So 2 plus 3 is equals to 5. So what's the next number here? 55, huh?
55.
Okay, so that is what? That is 21 plus 34 is equals to 55. After 55,
89.
how do you get that?
55 plus 34.
Yes, 55 plus 34, okay? 55 plus 34, okay, you get 89. So that is how we build this Fibonacci sequence, okay? So what is the term n? Nth term is equals to, okay,
N
if this,
minus 1.
okay,
N
term
minus 1 plus
n
N minus
minus 1 plus term n
N
minus,
minus
sorry,
2.
n minus 2, huh? N minus 2, okay? If this is term n, then to get 34, we plus these two numbers, right? 21 is term n minus 1. This is term n minus 2. Okay, if this is n. So to find Tn, term n minus 1 plus term n minus 2. We can write Tn, or we can even write Fn. If Fibonacci, we can write Fn. Okay, if triangular numbers, we can write Tn. If pentagonal numbers, we can write Pn. If square numbers, we can write Sn. Or we can use all Tn, term n. Okay, it means term n. Okay, so far okay?
Yes, madam.
Okay.
Okay.
Okay, another way of writing. Sometimes when you look at internet, you look in the internet and some books, they give you Fibonacci numbers like this. When you look at Fibonacci numbers, you see this pattern here. 1, 2, 1. This is 1. 2 plus 1 is 3. 2 plus 1 is 3. 1. Here will be 1. What should be here? If we follow this pattern here, 1, 1, 1. Then the third line here is 1. 1 plus 1 is 2 and 1. Then is 1. 1 plus 2 is 3. 2 plus 1 is 3. 1. So here will be 4,
4,
6,
6,
4, 1.
1.
Okay? This is actually Pascal's triangle. Okay? This is actually Pascal's triangle. But you can see the Fibonacci numbers here. How do we see the Fibonacci numbers here? It is like this. It's like this. This is 1, 1, 1, 1, 2, 3, 5, and so on. This here is another one next row. So this will be 8. Okay, this is 8, 8, and so on. So these are the Fibonacci numbers here. Okay, so this is another way of writing Fibonacci numbers. You write the Pascal triangle here, and these are the Fibonacci numbers that you add like this along the diagonal. Okay, so sometimes you will see Fibonacci numbers represented this way. Okay. Okay, so there's another way of representing Fibonacci numbers. this way. Okay, these are the Fibonacci number sequence at the top here. So we can draw it out like this in squares like this. Okay, this is 1. This 1 here is actually the dimension of the square. Dimension means panjang sisi. Okay, so this square, the dimension here is 1. Here's 1. We have 2 squares, 1, 1. So now we know that this dimension here is 2. This is 2, this is 2, so this is 2. All this together is 3. So we draw a square of 3. Okay, this 3, 4, 5. So draw another square of 5. Okay, and then 5, 6, 7, 8. So next square is 8. Okay, so this is 13. So we can draw another square up here, 13. See, all from here we can draw a spiral. Okay, so how do we draw the spiral? Like this. Okay, can you see the spiral there? That is called a Fibonacci spiral. Okay, let's do it again. Okay, like you have to, let me draw again. Okay. Okay, this is called the Fibonacci spiral, or it's known as the golden spiral. Okay, so this is how we can represent a Fibonacci number, either writing in number sequence or using squares like this. Okay, let me see how we can draw using squares. Okay, say if you want to draw using squares, we start with 1. This is 1 square, right? So this is 1 small square, side dimension 1. So this is 1, this is 1. So our Fibonacci numbers like this, 0, 1, 1. Okay, and then we have this side here is 2. So we are going to draw a square of 2 here. Okay, so the sides here are 2. Dimension is 2. This is 2. So this one, so this side here is 3. So we are going to draw a side of 3 here. Okay. Okay, 3, 3, 3, 3. Okay, so this is 3. Okay, and we know that this length here is 5. 3, 4, 5. So we draw a square of 5. 1, 2, 3, 4, 5 here. Okay. So this is 5. So this is 5, 6, 7, 8. So we can, all the time we draw rectangles. 1, 2, 3, 4, 5, 6, 7, 8 until here. Okay. Okay, so this is 8. And then this 8, 9, 10, 11, 12, 13. So let's draw rectangle 13. 1, 2, 3, 5, 6, 7, 8, 9, 10, 11, 12, 13 is right on top here. Here we until here, I think. Okay, so this is 13. Okay, so this is how we represent Fibonacci numbers in squares. Okay, and now we can draw our spiral like this. Okay, I think it's like this. Okay, like this. This is a side spiral. Okay, can you understand that? Can you do this? Can?
Yes.
Okay, so this is how you represent Fibonacci sequence using squares and using the golden spiral. Okay, now let's look at Fibonacci numbers in nature. Okay, these are Fibonacci numbers in nature. Okay, okay. If you look at this flower. Let's look at this flower first. Let's count the number of petals there are on this flower. Okay, 1, 2, 3, 4, 5, 6, 7, 8. There are 8 petals in this flower. And we know that the Fibonacci sequence, there are 8 petals, right? There are 8. 8 is one of the elements of the Fibonacci sequence. 2, 3, 5, 8, 11, 13. 13, 21, and so on. Okay, so we know that 8 is one of the elements in the Fibonacci number sequence. Okay, so we have 8 petals in this flower. How about this flower? How many petals are there in this flower? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 petals in this flower. 13 is in the Fibonacci sequence. How about this one? Can you count how many petals are there in this flower? Anybody?
Which flower, madam?
Sorry, this one. This one.
There's too many petals.
How many? Can count, isn't it? 1, 2, 3, 4, 5. Somebody said the answer. What's the answer? It's 34, I think. It's 34. Okay. So 34 is in the, this is the next number, right? 20, 30, 34. Okay. So there are 34 petals. Okay. So what I'm trying to tell you is that in nature, a lot of plants and flowers and seeds, seed arrangement, the number of seeds and plants and petals and all that, they all follow the elements in the Fibonacci sequence. Like this flower, 1, 2, 3, 4, 5. Maybe before this we were not so observant. We didn't observe these things. But after this, maybe if you can take a walk in your garden or around your house, just pick any flower that you see and count the number of petals and see if they correspond to the Fibonacci elements. Okay. So other than the number of petals, we also can see the number of spirals like this. Like this plant here, look at the number of spirals here. Okay, this is 1 spiral, 2, 3, 4, 5. 5 spirals here. 5 is a element in the Fibonacci sequence. Okay, and okay, and 1 meter. Okay, and this snail shell here, this shell here, how many spirals are there here? 1, 2, 3, 4, 5. 5 spirals. Spiral is anything like this. Okay, when you draw something like this, it's spiral. Okay, something like this is also a spiral. It even can make a pattern like this. This is also called a spiral. Okay, so if you look at this sunflower here, you see the seeds here. The seeds here also form a spiral. Okay. Okay, this sunflower picture here, okay? If you look at the seeds here, you can see spirals here. Can you see the spirals here like this? Okay. There are 2 different patterns. One is going this way, then one is going the other way. Okay. There's also one going this way, like this. Okay. So it can go anti-clockwise or clockwise, the spirals. So if you count the number of spirals here, which is a little bit difficult to do now, isn't it? So if you count the number of spirals, it will be a Fibonacci number. Okay. And this plant down here, you see the number of leaves, the way it is arranged is also arranged according to a Fibonacci number. Like this one is number 1. Then we have 2 leaves here. This 2 leaves here, 2. Then we have 3 leaves here, 3 leaves here. The underneath is another layer of 5 leaves, I think. 1, 2, 3, 4, 5 or something like that. Okay, so it is arranged in a spiral. Okay, 1, 2, 1, 1, 2, 3, 5. Okay, so these are examples of Fibonacci sequence in nature. Okay, the other one is here. This is a pine cone. These are the spirals on the pine cone. The number of spirals follow the Fibonacci sequence. Like here, if you see the numbers here, I think they have 13. I think 13. Okay, so these are all examples of Fibonacci in real life, in nature. Okay. Okay. Have you seen any other examples like this in nature? The other one is the pineapple fruit. Okay, if you take the pineapple fruit, you can see the spirals very clearly. Okay, that's what you're going to do later. Okay, you can see the spirals very clearly. The spirals, there are many ways the spirals can go. You can count the spirals clearly. Some will go anti-clockwise, some will go clockwise, some will go horizontally. Okay, it's how you see it. Okay, so when you count all the spirals, all the number of petals, the number of leaves and plants and all that, you will find that many of them follow the Fibonacci elements. That is why mathematicians are very interested in Fibonacci numbers. Okay. Okay, so now let's look at this problem-solving question. Okay. Okay. Fibonacci's original problem was based on this rabbit problem. Okay. His puzzle was, how many pairs of rabbits will there be at the end of 1 year? Okay, given that the newly born rabbits, say you have a newly born pair of rabbits, one male and one female, and these rabbits are put in the field. Okay, these rabbits are able to they take 1 month to grow to become adults. Okay, and then they can, at the end of 1 month, they can mate and they can produce a new set of rabbits. Okay, so do you understand that so far? So this first pair of rabbits are young rabbits. This is at the start of the first month. At the start of the first month, you have one male and one female rabbit. At the end of the first month, how many rabbits do we have? How many pairs of rabbits do we have at the end? If these rabbits live in ideal conditions. Ideal condition means the rabbits cannot die. They don't die. They have plenty of food and water. At the end of the first month, they can start to mate. Okay? And every month, the rabbits will produce one pair of rabbits. So at the end of the first month, how many pairs of rabbits will there be?
1.
Yeah.
2.
One.
Oh, yeah. 1.
1. Okay. At the end of the second month, how many pairs of rabbits will there be?
2.
Okay. At the beginning of the second month, how many pairs of rabbits will there be?
2.
1 also, right?
Yeah,
At the end of the second month, there will be how many pairs of rabbits?
2.
At the end of the second month, 2 pairs of rabbits, correct? So you see this sequence here. We have this first pair of rabbits here. Okay, this is the beginning of the first month, and then at the beginning of the second month, we also have one pair of rabbits, correct? Because this is when it's going to mate. It hasn't produced rabbits yet. Okay, so at the beginning of the third month, we have the original pair of rabbits and one new pair of rabbits. Okay, this is the third month, right? This is beginning of first month. This is second month. Okay, this is third month. Okay, beginning, third month. So at the beginning of the fourth month, this original rabbit will produce another, and this one will produce, it won't produce yet, isn't it? Yeah, it won't for beginning of fourth month, it hasn't produced yet, correct? Because this is
Yes.
beginning of third month, it takes 1 month to grow, so it hasn't produced yet. So beginning of fifth month only, it produces one more new pair of rabbits, and this one will continue to produce another one. So when we reach the 12th month, how many pairs of rabbits will there be?
For what month?
Answer this question. How many pairs of rabbits will there be at the end of 1 year?
$144.
144. Everybody agree?
Yes.
Is there any other answer? Okay, let's look at this. Okay, if I take this to be the beginning of the month, beginning of month. Okay, beginning of first month, how many pairs? 1 pair, right? Beginning of second month, how many pairs?
1 pair.
1 pair. Beginning of third month,
2 pairs.
2 pairs. Beginning of fourth month will be
3.
3. And then here will be 5, 8, 13,
31.
21,
34.
34, 55,
89.
89,
144.
144. This is beginning of the 12th month. What about the end of the 12th month? How many rabbits are there?
8.
Same, huh? Okay. So, okay, correct. The answer is 144.
4.
Okay. So, this is the original Fibonacci problem. Okay. This is the problem that Fibonacci posed to everyone. And from here, they developed the sequence and the Fibonacci numbers. This is where it came from. Okay. Okay. Okay, so we have finished with this topic, number patterns, okay? We finished with this topic, number patterns, okay? We're going to do one problem solving question first. We're going to try one problem solving question. Okay. This question, we're going to look at how this involves the whole of a number pattern topic, okay? You are stacking logs, you know what is logs, right? Kayu bala, there is enough space for only 10 logs side by side. How many logs can you fit in the stack?
100
How do you get the answer?
square figure
Square.
number square.
Okay, you know what's logs, right? We have a logs in Sabah Sarawak, right?
Yes.
Okay,
Yeah.
you know what is log. Logs are like this, right?
Ribana.
Okay, so we are going to stack. So they said there's enough space for only 10 logs side by side. That means on the floor maybe, or whatever you're stacking on, okay? There's only enough space for 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, there are 10 logs here, right?
Yes.
We can only stack. There's no more space. After this, there's no more space. Maybe say the wall is like this already. No more space for 10 logs. So after this next row, can we stack another 10 up here? Can we put one log on top
No.
of here?
No. Okay.
Cannot,
No.
right? We cannot put right on top of here. So how do we stack? We stack like this, right?
You need to. Yes.
1, 2, 3, 4, 5, 6, 7, 8, 9. We stack in between the logs, right? Like this. So we only can stock 9 here, right? We only can stack 9 here. Next row, how many? Next row, how many? How many altogether we can stack?
8,
8.
How many altogether? Okay, you tell me altogether. What's the
Oh.
answer?
55.
55. Why 55?
Triangular.
It is a triangular number.
Yes.
Term what? What term are you using? T?
The 10th. T10.
T10. So this is equals to
10 times
10.
10 minus 10 plus 1
10 plus 1 over.
over 2.
So this is 5 times 11, 55. Okay, okay, very good. Because this is a triangular number. If you keep stacking up here, how many numbers? What is the length of this? What's the dimension of this bottom here? 10, right? What's the
Yes.
dimension this way?
10.
10, yes. What's the dimension this way? 10.
Okay.
So this is a triangular number. So we want to find term 10. So we're starting from term 1 is on top here, 1 and then 2. We're going downwards 10. So we know the last one we added is 10. Of course, when we stack, we start from this way and go up. But when we calculate, we can calculate from like that. So we know this is term 10. So put in into the formula, we know that term n for triangular numbers is n into n plus 1 over 2. So substitute 10 and we get the answer 55. Okay, so these are the kind of problem solving questions that you will see under number patterns. Can understand that?
Yes.
Okay, so this is going to be your, okay, so when you do your tutorial later for Thursday, you will do the questions from week 8. From week 8, you have done question 1, 2, and 3. You have already done under week 8. So there's question 4 left. Okay. So question 4, you will use a graph paper. Okay. Use a graph paper and follow the question. Draw the Fibonacci numbers, and after you have draw the spiral on top of it. Okay. Although the question doesn't ask you to do that, but you do that. After you have drawn all the squares, draw the spiral on top of it. And then for tutorial 10 also, so you're going to answer question 4 from week 8 and all the questions from week 10. Later you see there are only few questions there, okay? So you answer all those questions for tutorial. And this is your task for you to do after this class, okay? Okay. Your task is, what patterns or Fibonacci numbers do you see when you cut a banana horizontally? I hope you have one in the house, okay? If you don't have, you whenever you get it, you try it. Take a banana and cut it horizontally and look at the pattern, okay? Once you cut it horizontally, cut it again and again and again and see the same pattern is there. And then try it on a few different types of bananas and see if you see the same pattern, okay? And then take an apple and cut it horizontally, not the way we always cut from top to bottom, but cut it horizontally, okay? And then cut it a few times horizontally and see if you see the same pattern, okay? And then take an orange, cut it horizontally and look at the pattern, draw it out, draw out the pattern and look at the numbers that you see, what number it is. And then examine the head of a cauliflower. If you have a cauliflower, look at the head and look at what do you see. Is there numbers or is there a spiral that you can see? If you can see a spiral, then count the number of spirals, okay? The same thing with the head of a broccoli. And also examine the patterns on a pineapple, okay? Take a pineapple and look at the spirals, okay? You can use a marker to draw the spirals one by one on the pineapple. You can use different markers to draw, or you can use cellophane tape or double-sided tape. You can tape along the spirals and then you write on the spiral the number of spirals, okay? And then you can take a photograph, okay? This is what you're supposed to do now for the next hour, okay? If you don't have any of these things, you can do this later. If you still don't have it before the next lecture, then what to do? Okay? So any questions?
Look up in the internet.
Pardon?
Look up.
The what?
Look
The
up in
task,
the internet.
yeah. Ask me again.
Looking up in the internet.
It still won't be the same as you doing it yourself, right?
Okay.
What they tell you in the internet is different. You look at it and then just walk around your garden, pick up any flower that you see, okay? And look at the number of petals. And some plants, look at the number of branches from bottom to top. Just count the number of branches and make a sketch. This is for your own enhancement, okay? Learning from the internet is one thing, but to go and experience it yourself, that's a different thing altogether. What you experience, you will remember always, okay? You will know the next time you eat an apple or orange, you will know how many, what is this number? You'll be really interested, okay? Okay? Any other questions regarding this topic? So we have finished with the number patterns already, yeah?